Hey everyone, and welcome. Today we're going to break down a core Java concept that's all about writing smarter, not harder. Multi-level inheritance. So how does this whole thing actually work? Let's dive in.
You've probably run into this a million times, right? You build a class, then you need a version that's just a little bit different, and then another version that's even more specialized. Now you could just copy and paste, but we all know that's a recipe for disaster. The real solution? It's building in layers, and that's exactly what inheritance is all about.
The best way to picture this is to think of your Java classes like stackable building blocks. Seriously, we start with a really general foundational block. Then we stack more specific, more detailed blocks right on top. And the coolest part? Each new block you add automatically gets all the powers and features of the blocks underneath it.
And that stacking idea, that's what we call multi-level inheritance. It's basically a chain of command for your classes. You have class C inheriting from B and class B inheriting from A. What does that mean for C? It means it gets everything from B and everything from A, all in one package. It's a beautiful, clean hierarchy.
So why should you even care about this? Well, it's incredibly powerful for a few reasons. First, code reuse. You write the general stuff once and never have to touch it again, which, let's be honest, is a huge win. It also lets you add new features in really small, logical steps, and it just keeps your whole project organized by making these is-a relationships super clear. You know, like a bulldog is a dog, which is an animal.
To make this all feel a little less abstract, we're going to follow a simple, hands-on example through this whole explainer. We'll start with a basic box. Then we'll add the concept of weight to it, creating a box weight, and finally we'll add a shipping cost to create a shipment. Let's see how these blocks stack up. All right, enough talk. Let's get our hands dirty and actually look at the code. We're going to build this shipment hierarchy one level at a time, just like stacking those blocks we were talking about.
So here it is, level 1, our foundation, the box class. It's about as simple as it gets, right? It just has a width, a height, and a depth. It has a constructor to set those values and a simple method to calculate the volume. This is our most general, most reusable block.
Now for level 2, we're stacking our next block on top. The box weight class extends our box, so it automatically gets width, height, and depth. But notice two really important things here. First, we add a new property, weight. And second, and this is the absolute key, we have this line, super, WHD. That one line is the secret sauce. It's telling Java, hey, before you do anything, go run the constructor for my parent, box, and let it handle setting up the dimensions. And here's our final layer, the shipment class, extends box weight. It adds its own special property, cost. And just like before, it uses super to pass the buck up the chain. It tells its parent, box weight, you go ahead and handle the width, height, depth, and weight. I'll just worry about the cost. It's a perfect chain of responsibility. So what's the big payoff for all this work? Well, when we create our final shipment object, it has access to everything from every single layer above it. It can use the volume method from the box class. It knows its weight from the box weight class, and of course, it has its own cost. It's the whole shebang, all wrapped up in one neat object.
This table lays it all out perfectly. You can literally see how the features cascade down. Box starts us off with dimensions. Then box weight comes along, adds its own weight property, but gets all the box properties for free. And finally, shipment adds cost and inherits the entire package from both box and box weight.
Okay, so we've built our stack of blocks, but there's this really cool kind of hidden mechanism at play here that we need to talk about. It's the order in which Java actually builds these things. I like to call it the constructor domino effect. So think about it for a sec. When your code says new shipment, which constructor actually gets called first? Is it shipment? Or does box run first? Maybe box weight. This order isn't random. It's super deliberate, and it's essential for making sure your objects are built correctly. And the answer is the top to bottom rule. It's that simple. Java always starts at the very top of the family tree, the most general class, and works its way down. So in our example, the box constructor runs first, then the box weight constructor runs, and only then at the very end does the shipment constructor finally run, general to specific, every time. So why does Java enforce this? Well, it just makes logical sense. My favorite analogy for this is baking a cake. You can't put the frosting and sprinkles on a cake that hasn't even been baked yet, right? You have to build the foundation first. A superclass has to be fully set up and ready to go before a subclass can come in and add its own special details.
And hey, don't just take my word for it. The proof is right here in the output. If we have a simple hierarchy where C extends B and B extends A, and we create a new C object, look at what gets printed to the console. First, A's constructor runs, then B's, and finally, C's. Top to bottom, no exceptions.
So we've seen this super keyword pop up a few times. This little guy is the engine that actually drives that whole domino effect we just talked about. So let's zoom in and break down exactly what it's doing. Okay, so super basically comes in two flavors. There's the implicit or invisible one. If your parent class has a simple constructor that doesn't take any arguments, Java just secretly adds a call to super for you. You don't even see it. But, and this is what we saw in our box example, if your parent's constructor needs arguments, you have to do it yourself. You have to explicitly type super, parentheses, and pass in the right values. And it absolutely must be the very first line in your constructor.
So let's just boil it down to the must-know facts. 1. Super is always the first thing that happens in a constructor, whether you write it or not. 2. It only calls the direct parent's constructor, which then calls its parent, creating that chain. And 3, this is a big one, if a parent class doesn't have a default no-argument constructor, you have no choice. You must call super explicitly yourself, or your code just won't compile.
And check this out, because this is where it gets really cool. You can use super to pass data up the chain. Here we've got a base, a mid, and a leaf class. When we create a new leaf, we call super with the string project x. That string gets passed from leaf up to mid, and then mid passes it all the way up to base, which is where it finally gets printed. See how that works? It's like a bucket brigade for your data.
All right, so let's do a super quick recap. Multi-level inheritance is all about building your classes from general to specific. Remember that each class in that chain gets all the goodies from its parents and grandparents. Constructors always run from the top down, and that little keyword super is the glue that holds the whole chain together.
And that's really it. Once you get the hang of it, you start seeing these patterns everywhere. A vehicle becomes a car, which becomes a Tesla. A person becomes an employee, which becomes a manager. The possibilities are endless. So the real question is, now that you know how to stack these blocks, what are you going to build? Thanks for joining me.